Welcome to yet another episode of Avail's Whiteboard series. Today we're going to talk to Sebastien from Paima, who's going to walk us through the architecture of Paima, the motivations, why he started building, and we'll dive deep into the architecture as well. So welcome, first of all, Sebastien. Very pleased to have you. Maybe Sebastien, if you could just start off with like a small introduction for our viewers.
Yeah, so my name is Sebastien. I'm one of the co-founders of Paima Studios. We're the world's largest roll-up framework for on-chain games and autonomous worlds, as well as we're one of the largest publishers of on-chain games. We build games ourselves. We target primarily EVM platforms, but also fairly cross-chain in our solution.
Okay. Thanks, Sebastien. So in general, before getting into the nitty-gritties of the architecture, can you talk a little bit about the motivations of like why you started Paima in the sense like why is gaming or a framework specifically for gaming so important? What are the issues that gaming developers really face while working with traditional solutions, and then how is Paima better?
Yeah, for sure. So when Layer 2s came out, the main thesis around it was scalability. How can we use Layer 2s to improve the scalability of Ethereum? I think definitely that thesis has turned out to work very well. Obviously, projects like Optimism and Arbitrum have been a huge success in that regard. But one thing that I really liked about Layer 2s is the ability to use Layer 2s for interoperability, adding new platforms to EVM environments. Right? EVM is a great solution. There's a lot of different architectures that have different trade-offs. And we've seen a lot of success in this kind of interoperability play. For example, Arbitrum recently added kind of WASM and Rust support for their platform. Projects like Starknet with Cairo have added ZK to Ethereum. And so we wanted to kind of expand on this ability to add new execution environments to blockchains. Now, one of the use cases that benefits the most from this, in my opinion, is gaming. Solidity is not that bad for DeFi, but if you want to write some large online game entirely in Solidity code, not only is this fairly difficult, but also it makes it hard to iterate. For a game, you want to push out updates on a weekly basis, keep users engaged, and it's very hard to do that in Solidity. Not only because it's a hard language to use if you have a large code base, but also because a subtle bug could cause users to lose all their money. And so we wanted a way to add a new environment to EVM chains that adds a better environment for building games. That way we can not only build games ourselves for EVM platforms, but also allow other builders who want to build games to do this without having to spin up a whole new Layer 1 blockchain.
Okay. So in what aspects, like what are the aspects that you generally optimize for from a gaming development point of view, right? Like what are the what specifically do you make it easy for gaming developers to get started, for example?
Yeah, great question. So usually when you're writing a game, you can think of two parts of your game that matter. One is your Solidity component. So you have some Solidity code, and this will power the composable part of your game. Which parts of your game need to interact with the rest of the EVM ecosystem, right? Inside this, you might have your ERC20 or your ERC721, NFTs and all these other assets. And so typically you want these to live on the Layer 1 or maybe on Arbitrum or one of these other chains. But you want this to live on the most interoperable layer that you can get, right? But your games often have like a part that does not necessarily require interoperability. For example, if you have a lobby system, a matchmaking system into your game, you don't really need all the other dApps on Ethereum to know about the state of a matchmaking lobby. And you pay a cost for that because if you want to have it interoperable, now you need to write it on Solidity, you need to pay the high gas fees. And so what we've created is, with Paima, you can create basically an app-specific Layer 2 that is a state machine. So a state machine, if you're not familiar with computer science, it's basically like a diagram of state transition. You say, okay, we start here, and then when you make the transaction, it goes to the next state. When this happens, it goes to the next state. So Paima facilitates you writing these kind of state machines in JavaScript. So it allows you to easily write these state machines. You don't have to know how to write any Solidity. And you write your state machine, and then we allow you to turn that into a Layer 2. And so it'll post all the call data for that state machine directly into the EVM layer. So that way, just by synchronizing the Layer 1, not only do you get all the composable part of your games, you get also all the call data for the state machine. So you can also rebuild the entire layer 2 state just by synchronizing the layer 1.
Okay, so what you're primarily saying is that you've been bifurcating the requirements for a gaming developer into two parts, right? Like, so there is the more, let's say, trading or interoperability bits. Like, for example, users want to swap tokens to get into your game, for example, ERC20 tokens, or they want to buy or sell ERC20 assets. That happens on either the layer 1 or maybe even a layer 2.
Yeah.
Like Arbitrum or Optimism or Polygon. But for the more game specific logic, you have this separate state machine or roll up that primarily is more like a pessimistic construction at the moment.
Yep.
It could be optimistic or ZK later, as you've mentioned before. But essentially, you write those states into call data, for example, and then so that at least anyone is able to reconstruct that if they want to.
Yeah, and our goal is to essentially make the game development experience as easy as possible. So as a game developer, we would like us that you only have to focus on this part. So we're also building a primitive catalog as part of Paima. So if for your game you want an NFT or you want an ERC20 token, you shouldn't have to figure out how to write all these contracts and figure out how to deploy them. So we're building out this primitive catalog. So as you're writing your state machine, we provide you a configuration file. You can say, okay, for my game, I also want an NFT and all these kinds of information. And Paima will handle deploying all that for you to layer 1 if it doesn't already exist. And then it will connect this to your state machine. From your JavaScript code, instead of having to connect directly to the API and do all this kind of work, we instead pass all this in as like events to your state machine, so your state machine can update. So we kind of try and abstract this away from the users. Not only is this important for like ERC 20, 721, 65F1, these kinds of other standards we support, but for a lot of games that we've talked to, a lot of projects we've talked to, they don't want just Ethereum layer 1 support. Ethereum layer 1 support is obviously super important because that's the largest NFT marketplace volume. And so a lot of projects want their NFTs to live there. A lot of projects we've talked to have wanted to take advantage of other layers as well. For example, they say, okay, I want my NFT to live in Ethereum layer 1 or another layer 1 like Polygon, BNB Chain, Cardano, some of these other platforms. But I also want to take advantage of Arbitrum for the faster block times and lower fees. And I also want to take advantage of Avail for the DA. And I also want to take advantage of another ZK platform like Starknet, like Mina, or some of these other platforms for the ZK. And so they come in with all these requirements for their game. And right now the layer 2 ecosystem is fairly fractured in functionality. We have different platforms providing different functionality. And so when we build a version 1 of Paima, we basically build this is simple, like creating a layer 2 for a single layer 1. We realized like what people really want for a gaming use case is more of a sharded rollup solution. So notably, like up till now, most layer 2s are layer 2s for a single chain. Like it's a layer 2 for Ethereum, or a layer 2 for Polygon, or a layer 2 for BNB chain. We've seen the growth of 2-chain layer 2s. Like it's a layer 2 for Ethereum and Celestia, or a layer 2 for Ethereum and Avail. So there's 2 nodes you have to sync together and join together to get the full rollup state. So what we realized with gaming for Paima is that for a lot of these games, they basically want a lot of other arrows. So they might say, okay, I have layer 1 for the NFT, and then I have Arbitrum for my settlement layer, and then I have Avail for my DA layer, and I have Mina for my ZK layer. And then for some projects we talked to, in fact, they actually want like NFTs on multiple chains. They say like, oh, I have a community in like Cardano because I got a grant from there and I want my community to be there. But also like I want to bring in new people into my brand, new people into my ecosystem. So I also want some kind of Ethereum NFT collection. So they maybe want to have like multiple layer 1s. Like maybe they want Ethereum and Polygon or Ethereum and BNB chain and connect these two together. And so we've noticed that a lot of the projects want this kind of requirement. And so we kind of made Paima more of a sharded rollup framework to allow you to aggregate events from all these different chains into your state machine. And so a lot of the challenge of Paima is building this primitive catalog to make it as easy as possible for people to gather stuff from all these chains, because realistically a game developer, not only do they not know Solidity usually, like they definitely don't know all these other platforms. And so we need to make this experience as easy as possible for them.
Okay. Okay, so I think I now trying to am able to understand. I think where you're coming from is that assets, NFT assets, or like ERC20 assets are distributed across chains, and so users want to access them where they can.
Yep.
And then you have the specific game logic in the Paima rollup, which is more about getting the events from all the other chains and then executing the logic. But I'm just curious how the user experience from a single user point of view, right? Like if you have this multi-chain presence, what is the UX like for the typical user? Because essentially, I can understand the gaming bits because that is primarily on the Paima rollup, but all these assets across chains, right? Like, isn't that a problem for the UX?
Yeah, so Paima also comes with the batcher SDK, like a sequencer SDK essentially. And so this comes with Paima, so you can deploy your own batcher. We have all the logic for you. This batcher is aware of all these different, frameworks and knows how to post to them. So if you want to deploy a game that manages all these different platforms, basically anybody can run a batcher, but you, of course, as the game developer, can run the batcher yourself, and you won't have to write, support for all these networks. They're built into the batcher, and so we'll try and abstract all that for you. And then now, as a user, instead of writing to Mina, instead of writing to all the different layer ones, because they might not have wallets for those ecosystems, they might not have coins in these ecosystems. Instead, they interact directly with the batcher that facilitates, posting across all these ecosystems for them. The goal essentially is that from a user, for example, if you are an Ethereum user, the goal is that you always play with your Ethereum wallet with Ethereum NFTs, and you shouldn't have to know all these ecosystems. If you're coming from another blockchain, like maybe you're coming from Polygon, you have your Polygon setup wallet on MetaMask, and you play with your Polygon NFT. If you're coming from Cardano, you have your Cardano wallet with your Cardano NFTs. We want to try and abstract this away from users so they feel like it's a native experience, and we kind of abstract all this away from them.
Okay. That I understood about the batcher. But what about the actual assets, right? Like when the user has to interact with those assets, right? Like let's say they're doing an NFT buy or sell, or they want to, swap from, let's say, ETH to USDT, like whatever, to use in your game. So then it still defaults to like a chain specific transaction, right? Like, I mean, when you want to do a transaction on each of this, right? Like, so, just trying to understand, like, what is the UX there?
Yeah, so I think one important thing to note is that Paima is a non-custodial rollup solution. So, for example, if you're using a platform like Optimism and Arbitrum and you want to call a dApp that lives on that platform, first you bridge to layer 2, then use the dApp. Paima doesn't work that way. So as you notice, like the assets always stay on the layer 1. So they never get moved into layer 2. And the reason we did this is primarily to avoid bridges.
Bridging.
So like people are always scared of bridging with ETH or just ERC20s, and let alone like bridging with ERC720s, which has just never gone popular. And so we've noticed that people just want to keep their assets directly on layer 1. And that makes especially a lot of sense for gaming use cases, because for gaming, you need to be able to iterate fast, get updates every week. And if you have to change your code every week, you're introducing a new possible vulnerability every week. And so by being a non-custodial solution, it means that even if your game, your state machine has a bug in it, user assets are not at risk, they're staying on the layer 1. And so by separating the assets from the game state machine, you're also helping extra safety for the user. So that's how we kind of set it up. For the user's side, as I mentioned, we're working with a batcher, and the batcher comes with an account abstraction framework built into it, and that's also supported by the Paima state machine. And so we're trying to facilitate that, as a user, you simply interact with a batcher, which has support for this account abstraction framework that can help facilitate your actions inside the state machine, no matter which network you come with. So we have support for Mina and EVM and Algorand and Polkadot. We're trying to add all the ecosystems supported into our account abstraction framework, so that no matter which ecosystem you come into, the batcher can help do the translation required for any network.
Okay. So now I sort of understand. So it is like a fresh perspective, I think, in the sense that, like you say, right? Like, so this is basically like generally you are right. The approach is to for users to bridge into a particular, let's say, environment like the L2 for example, and then the gaming DApp also lives there, and so you kind of conflate, like you combine both of this, and so that leads to a UX problem. But here you're saying that like you don't really you do the bridging, for example, right? Like the game lives on the Paima rollup, but the assets live wherever they are, and then essentially you kind of like sync the state to the rollup. Yeah, that's pretty interesting actually. Have you thought about using something like storage proofs to kind of like make this syncing more trustless?
Yeah, so the next natural question is, okay, well, we have this architecture, but how does it actually work? How do we actually get layer 1 state into layer 2? And there's many ways we can do this, all of them which have different trade-offs.
Yeah.
Obviously, the easiest solution from an engineering perspective is just the roll-up node monitors every single chain. Just like, for example, if you're running a layer 2 that uses Avail, you usually have an Avail node, and then your roll-up node actually talks that Avail node directly. So that's the easiest solution. Now, there's some problems with this solution. One is, of course, it increases the infrastructure requirements for your layer 2 node. Now you have to sync multiple chains. So this is a trade-off as a developer you have to make. But not just that, also these layers might not have the same finality, might not have the same block time. And so you also need to make sure that the block times and everything aligns.
Yeah.
So what we've created for this is a system we call Projected NFTs. Which is our system for taking this NFT state and projecting it into layer 2.
Okay.
Notably because for some applications, like for example, a token gated feature in your game, you want an area that's only accessible if you own an NFT. Maybe it doesn't matter if the data is 5 minutes behind because you're waiting for finality. As long as it's happening, it's fine. There's some use cases where your actions in the game actually affect the value of your NFT. Maybe your NFT owns gold coins, and if you lose the battle, you lose all your gold, right? And so you want to make sure that the user, they do not sell their assets on layer 1 right before they lose the battle on layer 2, right? And so with the projected NFT system, we've essentially created a time lock system in a sense. So you can lock any asset you want, like in ERC 721, you lock your asset and you can unlock at any time. So it's not a bridge, you're not giving up custody of your assets to anybody else. So you can lock and unlock any time. When you unlock, instead of getting your assets back right away, it starts a timer. And then once the timer expires, then you can get your assets back. And that timer is crucial because it gives, for example, 2 minutes for every other layer in your ecosystem and Paima rollup itself to detect the change into your token.
Okay.
So
I think,
so these are like, 2 potential options that we provide out of the box. Of course, we're also super interested in storage proofs like Herodotus and what they're doing. The trade-offs there usually like ZK coprocessors have a certain amount of time that it takes to not only create the proof, but bridge the proof across networks.
Yeah.
And so for those use cases, that's also something that we're interested in adding into our primitive catalog so that the game developers, if they want those sets of trade-offs, they don't have to figure out how Herodotus and storage proofs works. They can just use the primitive catalog, add that in, and get that possible, possibly usable inside their system. Another one is called like mirroring NFTs, which is more of like a centralized solution, which is to say like, okay, if you want to use this 721 inside the game, you basically say, do some kind of locking system here. And as soon as you lock here, some centralized oracle will update the state machine to assert that you had a lock. And so with like the NFT mirroring, you don't need like this unlock withdraw period.
Okay.
So like you get rid of the kind of slow unlock. But also now you're introducing a centralized third party that has to kind of attest that the lock happened on the L2 side.
Okay.
So there's 3 different solutions with different trade-offs. We took the projected NFTs as the first approach because it's fairly easy to understand conceptually and has the lowest trust requirements. We're also interested in adding all these other options to our primitive catalog.
Okay, makes sense. And so just to clarify on the projected NFT thing, so this is for, I'm presuming you have like a lock unlock implementation in the template NFT template code that you have.
Yes, exactly.
Yeah, okay. So typically the gaming developer flow is that like they will, like once they start thinking about this game, So of course, there's a gaming logic which they can define in JavaScript on the Paima rollup engine. But on the asset side, like so they can mint these assets like with your custom template.
Yeah.
With the projected NFT logic.
Yes, exactly. And so the way we add value to these assets and help make the game have financial value is this concept of a stateful NFT. So essentially, when you're playing the game, you usually want to associate your game actions with some NFT you own. And then the game node that you're running that powers your layer 2 essentially has RPC endpoints that output information about the game. So similar to ERC20 tokens, they have functions you can query to get information about the ERC contract state. Paima layer 2 kind of works the same way, where you have these endpoints where you can query and get information about the game state. And so, for example, you can ask for a specific ERC 721, what is the game state of that token? How much gold do they have in game? Which equipment is that user wearing? And you can take that information and add it back to the ERC 721. And this allows you to have your Ethereum layer 1 NFT, for example, evolve over time based off your actions in layer 2. That means that you can monetize in-game progress. Like, for example, how many quests have you completed? How many achievements have you gotten? This kind of in-game information, as well as items and things that you've done in-game, can be added to your NFT state and then traded on the open market. For example, OpenSea or an app-specific NFT marketplace.
Okay. And this is, I'm assuming, through the batcher, this update happens, and this is actually a update to the NFT, like a transaction here.
So this is optional. So for some games, you might want to actually make some function call into the NFT to upgrade some data. For a lot of games that come and talk to us, they already have an NFT collection, and it's kind of too late for them to modify it. So you don't necessarily have to modify your NFT smart contract. The combination of these two states can be implicit. So for example, if you have an NFT marketplace for your NFT collection, you can say, okay, get the user's NFT and then query the game node to get that state and then merge the two data into your UI inside your NFT marketplace.
No, makes sense. I think this is good in general. So can you walk us through, like, let's say, typical game flow? Like, what are the, like, just for viewers, like in general, what are the integration points with like more blockchain infrastructure, right? Like, and what is, like, there's a game element, and then there's, like, what are the data points that are really useful in your experience with working with gaming developers, right? Like, what are those important points that people really value to be like coordinated through the blockchain, right? Like, I mean, if that's a the right question to ask.
Yeah, so for a lot of projects we talk to, they're usually NFT collections, right? So of course, Paima doesn't have to be for NFTs. You can build a game that's a new project entirely, or you can even use this for gamification use cases like carbon credits or proof of attendance, anything that is game-like in nature. Obviously, you can use Paima for. The number of clients we have that's most common is NFT projects. They have a NFT, they have a brand, and they want to gamify that brand. And through the gamification, they want to increase user engagement, increase user retention. So usually how that works is, they have an ERC 721, they add it to their game using the gaming primitive catalog that we've built, and then start working on their state machine. Once we have the state machine, we also have some templates for Paima for different front ends. So we have front ends in Unity and GameMaker and various JavaScript frameworks. And these front ends, through the templates that we provide, can connect to their state machine. So they come in with their ERC 721, they build the state machine, or they ask us to help them write this for them, and then they connect this to their front end, and that's what they end up deploying to the ecosystem. So we're trying to minimize the amount of work that they have to do. So we have templates for the front end, templates for a variety of state machines. Like we have card games, we have arcade games, we have RPG games, open world games, Web 2.5 games. So trying to have as many of these templates as possible so they can take these, modify it as they will, decide to run a batcher or have somebody else in the ecosystem run a batcher for them, and then they're good to go to deploy their game to their ecosystem.
Okay, makes sense. And so basically, like, so again, just to clarify, right? Like, so what have been the most important like Web3 elements for gaming developers in general, or like gamification in general? Is it like the NFT that is useful? Is the on-chain game state useful? Like what is really the selling point for gaming devs or other similar devs that you are targeting to use like not only Paima but in general blockchain systems, right? Like I'm just trying to understand a little bit.
Yeah, for sure. So for a lot of these ERC 721 projects, these NFT projects, it's about increasing user retention, increasing user engagement, how you get people to interact with your brand. Gamification in general has like a lot of financial interest. So for example, we've seen projects like Axie Infinity do very well, but Axie Infinity never reached the same market cap as Shiba Inu or Dogecoin. And you have to have a thesis, why did it not reach that market cap? Now, my personal opinion is that part of the reason why is because Axie Infinity, at the end of the day, it's controlled by the company behind the project. And so it can never become this kind of meme coin like thing that takes on a life of its own. And by building your system fully on chain like we allow with Paima, it allows the game to kind of take a life of its own and possibly reach those higher market caps. So a lot of people see the potential value in building fully decentralized gaming experiences. But also we've talked to a few developers that they want to build a really cool game on a mobile device. And so they build a cool game experience, they give this out to their players, and the monetization of the game is primarily microtransactions. So people get on the bus, get on the train, start playing the game, pay for the game. And at some point, the game is just no longer profitable and the game shuts down. It's obviously sad for the developers, but also sad for users who paid a lot into the game only for the entire state to disappear. So also by engaging with these Web2 developers and saying, like, hey, if you build your game with Paima, you can still give, because of our account abstraction framework, a very Web2-like experience. People can play from their phones, they can play with their email, they can play no matter which cryptocurrency they want to use, they can just get in and start playing the game. And they have an assurance that if they start playing the game and pay for it, the game will not just randomly shut down and they lose all their progress, and they can enjoy the game as long as there's a single person interested in running essentially the roll-up node.
Okay. I was just curious how like this like a more complex. So more complex example of a game or game logic that you've helped integrate with your framework, right? Like I mean, like I just trying to understand the gamut of options or games that people are increasingly developing. So that like we understand the scope of the games, because like there's this perception that like games in Web3 are overly simplistic, very like more financial in nature. But I think you are doing some great work, so it will be useful to expand on like maybe a more complex sort of game and then how it fits into the framework.
Yeah, it's a great question. I'll go through two examples of games we're building. The first one is called Tarochi, which is an on-chain RPG game that we are writing. Probably by the time this video comes out, the public alpha will be released. Anybody watching can go check it out.
Oh wow!
So this is on-chain RPG game. So there's no centralized server required at all to play the game. The way it works is we wanted to delay the manual blockchain interaction as soon as possible. So when we built the first version of Paima, we originally thought, okay, whenever people start playing the game, they'll get an NFT right away. Similar how if you have a Web2 experience, you create an account right away on RuneScape, on World of Warcraft, you create an account to start playing. We noticed that a lot of people would actually, bounce back. Like they would stop right as soon as the login page happens because they see the game is, maybe for Ethereum, they don't have an Ethereum wallet, or maybe they're too scared to connect the game to their Ethereum wallet, and so they would, stop playing. So for Tarochi, we said, okay, we'll try something else. Instead of having the user mint like an account NFT right away, we'll just associate their data to their wallet. And with account abstraction, we could have that wallet be an email login or anything else. So they can start playing, right away without having to mint the NFT first. Our second, attempt was, okay, as they're playing the game, when they get items or they get monsters, that's when they mint the NFT. And that NFT keeps track of the monster state, their level, their health points, their moveset, all this kind of information. We noticed that this only kind of delayed the issue. People will play until they get to the monster stage. They catch the monster and it says, okay, now to mint your monster as NFT, connect to your Ethereum mainnet wallet. And they're like, well, I don't have an Ethereum mainnet wallet, or I don't want to. And so they would, stop playing the game at that point. So we realized that to really get the users to commit to the game, we would have to delay the actual minting of the NFT all the way up until they decide that they want to mint something. And so what we've essentially created for Tarochi is that all the information from your actions to your monsters to your items, all this stuff is all just associated to your account abstraction wallet. And at any point, you can decide to bag your game state into an NFT. So we essentially say, okay, all this call data that was posted to, for example, Ethereum over these past few blocks, take all this data, bag it together, and mint it as an NFT that is either back on Ethereum layer 1 or minted as an NFT on Arbitrum. We're also trying to provide some other options for other layer 1s as well, like Cardano. So when you actually want to bag your NFT, usually it's because you have an NFT marketplace in mind. You want to go to a Tarochi NFT marketplace, or you want to go to OpenSea, or you want to go to JPEG Store or some of these other NFT marketplaces, and you know exactly what you want to do. And at that point, now you're okay with doing the wallet connection flow and connecting your wallet and so on. And so we tried to delay this kind of NFT minting as long as possible to provide this experience and increase user retention. We found that this has had the biggest success. And so the way Tarochi works is, all the NFTs, but also like NPC interactions, the achievements, the quests you do on chain, all these by default are just, stored in this, temporary data that we allow you to bag into an NFT at a later point.
Like, can you give us some concrete data on like whether users, like what is the utility for users for like bagging those NFTs in general, like in terms of storing the game? It's actually like in conventional Web2 land, it's like storing game state, right? Like saving game state on the server.
Yes, exactly. And so the difference is that this game state, this bag that you've created, can now be listed not only on NFT marketplaces, you can also potentially list this on like AMMs for NFTs. So for example, like a lot of different monsters in the game, might have a very similar price. If it's same rarity, same level, you might not want to list on OpenSea because then the liquidity will be fairly fractured. So you might want to bag your monsters into a bundle at a specific price point and then list it on an AMM that facilitates liquidity for any NFT bag worth approximately $10. So also like the ability to bag state together to try and hit a specific price point to get it traded easily also helps a lot with like the liquidity.
Okay. So this is like if I'm understanding this correctly, this is like me going to like Dota, for example, playing like leveling up a few up to some stages, for example, and then kind of selling that on that account on the secondary marketplace so that other people can then start off with those game states.
Yeah, or for example, on RuneScape, there's a grand exchange where players can trade against each other and sort of facilitating, taking these game items, these games that you've collected, listing on an exchange and allowing you to trade with other players. So there's examples of, games in the Web2 space also building these, kinds of marketplaces. The main difference is that through Paima, there's no centralized company in charge of the marketplace. Rather, this is an open ecosystem.
Open ecosystem. Yeah. No, makes sense. Like what kind of users are you seeing playing these games, right? Like, I mean, see, one problem or like complaint that we receive generally, right, like in the Web3 space is that like these are not serious gamers. These are just basically like more of financial like users, for example, right? Like, so how do you kind of tackle that complaint with what you're seeing with your users, with the kind of games that you are building or helping enable?
Yeah, and I think a reason that kind of happens, especially in the on-chain gaming space, is because a lot of the people who made on-chain games in the past were doing this in fairly limited frameworks where they have to use Solidity for everything. And so you cannot build like large open experiences like Tarochi, which is a world with multiple villages, multiple maps, vast kind of world experience. And so they're primarily looking at historically, like, how can we build a game that has a financial aspect to it? Usually it's like a gambling directly or indirect gambling. In which case, like, there needs to be a financial aspect for people to play around and try this out. For Paima, we definitely can support this kind of use case, but we as a company are trying to focus more on world building, this kind of concept of building an autonomous world and driving value to the actions in that world. And so Tarochi is not the first game we've built. We've built some other games in the past. Notably, we built a on-chain tower defense game where basically is a PvP tower defense. One player places the towers, the other player places the enemies. And we had about 1,000 unique players for that game that came in and tried it out. And this was before we had our account abstraction system built in. And so you had to sign every transaction manually, and there's no financial reward for playing the game. But despite this, people enjoy the game, came in to try it out. For that game, we had the batcher. So we didn't have the account abstraction yet, but we had the batcher, so people could play for free. And so we even had people who were 11 years old come in and play the game and enjoy the tower defense experience. Because one of the main barriers of crypto right now is because you need a wallet to interact with these applications. Only people who have money available, aka adults, will be able to play the games. But through a system like Paima or through the account abstraction framework and the batcher system, people don't necessarily need to have a wallet, don't necessarily need to have assets. You can also allow more age groups, more kinds of players to come in and play that experience. So with Tower Defense, we had about 1,000 total unique players across the history of that game, which is obviously still very far from Web 2 games, but from a on-chain game perspective, it's actually a very up there in the kind of rankings. And so our goal with Tarochi is by building with more account abstraction frameworks that improve that user experience, as well as building a more vast gaming world that we can kind of exceed those player counts. And the goal is essentially at the end of the day, provide a good alternative to the metaverses created by Epic Games and Facebook, which are billion-dollar closed gardens that they're trying to control, and we want to provide a viable decentralized alternative to these platforms.
Okay, makes sense. So as more of of course you talked about Meta, for example, and others, what are the sort of for our audience, right? What are the sort of tools that you or the your target customers currently use for, let's say, world building or that kind of thing? Are there any new improvements to technology, especially on, let's say, the AI side, that makes this easy for you to do? What is the current state? Because I'm not an expert, so I'm just asking in general.
Yeah, for sure. I mean, definitely with tools like ChatGPT, it makes it easier to have a kind of sparring partner to decide how the story should evolve, help write the character dialogue, as well as with platforms like DALL-E and Midjourney makes creating the art for these games much easier. We're also super interested in using AI to help grow the world state.
MPC wallets, these have they're still very Web 2-ish in the sense that you can sign on with Google Sign On all, but it's a very good MPC construction on the server side. You have this threshold signatures, and there are some trust assumptions, but mostly pretty much non-custodial.
Yeah, I think the key thing about Paima Engine, one thing I think makes us different from a lot of people is we're trying to reuse as much as possible.
Yeah.
We're not trying to recreate our own ZK layer, not trying to recreate our own optimistic rollup, not trying to recreate our own DA layer. We're trying to leverage all the tools by other people and provide a quick aggregation layer for this. And so super happy to work with as many wallets and account abstraction frameworks as possible. Because at the end of the day, of course, we're an infrastructure company, but we're also a game development company. We have our own games that we're working on, and a lot of the stuff we're building is because we have our own games that we're building. We find these requirements, and we want to solve these problems, not just for us, but solve them for everybody. And have all these solutions available on GitHub. So super happy to work with any new construction and help make these available to everybody.
No, makes sense. I think this was pretty useful. I mean, actually, people talk a lot about gaming in the Web3 space, but so this shows a very opinionated way to do gaming frameworks in Web3. And I really like the clarity in terms of disambiguating game logic and asset logic and all the different approaches for with different trade-offs. And I like this idea of aggregating all these ecosystems because right now, of course, we are on this whole infrastructure expansion view, but on the application side, you really need this to be abstracted away as much as feasible and possible. So yeah, really refreshing take on the entire framework building. So I mean, yeah, great job, Sebastien, in general.
Thank you. Well, we're also integrating Avail into our platform. So that's the first DAA layer we're integrating into Paima. So very much looking forward to continue working together and enabling not only us but also other game developers that want to take advantage of Avail's functionality to do so without having to know how Avail works. Just add this into their primitive catalog and start using the amazing tech that you've built as well.
Yep. Thank you, Sebastian. So yeah, that's it, guys. I mean, hope you guys also like this session. Yeah, I mean, I had a great time understanding the internals of Paima, and thank you, Sebastian, again.